Let's talk about organic markdown's reference syntax. So to do that, I want to create another section here. Maybe we call it saying hello. So it's a section that we're dedicating to documentation for the process of saying hello. Here it's just a printf, but it may, in some other scenario, you could conceive of a situation where that process needed maybe some more explanation. So in order to not have to just document everything up here next to this particular snippet, Literate programming was designed to allow you to pull sections out and defer their complexity, the code complexity, for a later section so that you can explain it. So you can see how parsing out these sections like that gives you an ability to individually address different topics and document them and make the overall presentation much more understandable. So here, if we create a section and say we call it say hello, let's just put let's see. Let's just copy it and paste it down there. So now what we do up here, in order to reference it, is we reference it by name with this syntax, this @ sign less than, and then also @ sign greater than. So we would say hello. So we come down here and confirm the name is say hello. So this, if it worked correctly, should just, when you tangle this code, it should show up in the right place in the file, but here we have it all pulled apart. So let's say hello refs. Okay. So let's tangle, and then let's see what we got. And it says hello refs, which is what we'd expect. So you can also do this sort of referencing an arbitrary number of levels deep. So say we wanted to say hello to someone. We could also do a reference here. And then have a section here that says, that's called name maybe, and we'll say name equals let's say like, yeah, name equals name. Okay, and then let's just put Adam Ard in there. So now we have a say hello that references this one, and we have a name that references this name, and then we have my name in there. So let's save it, and let's tangle, and then cat. So hello Adam Ard. So you see it can go any level deep. So there's also a way in references to specify a default. So say for example, we don't have a name, we forgot to put it in there or something. We can have a default in here. So let's say like Joe Blow. So now this will check for a reference, but if it doesn't find a reference, it's just gonna use Joe Blow. So we'll tangle hello Joe Blow. So the other thing that's cool about these references is they can also take arguments. So up here, if we wanted to say, no, I really want the name here to be John Doe. So now it's going to preference an argument. So when it looks, it'll look for a reference or an actual code section or an argument or it'll defer to the default value. So in this case, we should see it change to John Doe, which it does. So that's good. Now, these code sections, also something that's important to note is that these code sections will append. So if you have two code sections with the same name, they will just append to each other in the order that they're encountered in the parsing. So say I had a section called includes, or let's see, we'll call it first include. And I said name equals includes, and I could say standard io.h. So up here, I could say includes. And since that matches that name, when we tangle this, it should just show up the way that it did before. So we'll double check. So it did. So now if we want, say we wanted a second include, we can create another section. Let's make this a section there. So we can say name. Now if we just make it the exact same name as up here, so you can see name equals includes, name equals includes. So now the behavior is not that it'll overwrite, but that it'll append, which is kind of the default behavior as far as I could tell in most literate systems. And from using it, that tends to be convenient for a few things. So now we should see this section should end up with 2 lines. So we'll see what happens now. So now you'll see that it showed up as the second item, standard lib. So also it comes prefixed the same way that the previous line did. This is kind of a cool little feature that's in literate systems too. So if you have some code that's prefixed by something, then it'll if this reference has more than one line, which it does in this case, because we've just repeated it and it's appended. So now this is 2 lines long. Then it'll reuse the prefix on every line. The way we could double check that that's what's going on is, or to demonstrate kind of what's going on there, is you can also do this so that your one reference has a couple lines, and then it should do the same thing. This is kind of cool for lots of things. So say you wanted to just comment that line out. Since this has several lines, you want both those lines to be commented out. So then you see that they both get commented out. So there's lots of reasons why that's convenient, and that was another thing that Donald Knuth came up with. So lots of these little details of the literate system come from him, and he came up with a lot of very helpful conventions that make programming with literate programming very convenient. So I think that's it for explaining literate references.